Welcome to the DeWare Black Tech. Now we will see how to implement the full adder. So full adder means it is just addition of the A, B and the C in, and that circuit will going to provide the sum of the A, B, C in and the carry out. Okay, C in and the C out. Then A, B and the C in are the inputs, and sum and the carry out are the outputs. So the equation is like I'm just going to show you the truth table and the equation. The truth table is 0, 0, 0 and 0, 0, 1, like that. There are 8 possibilities, and the equation is like sum equals to A XOR B XOR C, and C out is equals to AB plus BC plus C in. That means AB plus BC plus CA, or AB plus B into C in plus C in into A, like that. The equation, if we try to make the equation from the truth table, it is going to give like that. So now we are going to implement this in the FPGA board. So for that, first of all, we just have to go to the ISC tool. Here we have the board, and just go to the ISC tool, then just type ISC. Then this will going to open the project navigator. Then just click on this OK, then click on the file and the new project. Then this, we call this as a full adder. Okay, so full adder, I just named this as full adder 1. Then okay, all these things which depends upon the board, what are the things that is board, we just have to fill. So here we have all these things, configurations. I think you can see here. That is the Spartan 6, XC, 6, XL. These things, it depends upon the board specific. Okay, depending upon the board, we just have to fill that. Then click on the next, then click next and click finish. Okay, so here new source, and go to the Verilog module. We are going to write that in the Verilog, that is using the data flow modeling. So here I'm just going to call this as a full adder, then click next. Okay, here you can specify that itself, or you can even specify in the program. So for the time being, I have the program for the full adder here. It is just like the full adder, that is the module, and here we have the port declarations. Then here the output and the input. Output is the sum and the C out, and input is A, B and the C in, and assign is the keyword that we have to use in the data flow modeling. So assign sum equals to A XOR B XOR C in, then the C out equals to AB, that means A and B. Plus is represented by the OR, so A or AB or B C in or C in A. Okay, so this is just a simple code for the full adder that I just have to write here. Okay, full adder. Okay, full adder sum carry. Yeah, this is what we have. And okay, we just simulate it first, then we will implement this to the board now. So just go to the simulation. Here we have the option for the implementation and for the simulation. Just go to the simulation and create the new source. That is the, for simulation we have the Verilog test fixture. Okay, then I'm just going to call this as a test bench. Then click next for the full adder, then click finish. So here it will automatically going to create the test bench for this, and we just have to add a something like initial begin, then A equal to 0, B equal to 0, C in equals 0, then 100. That is, it is already generated for only one, that means one trial, 0, 0, 0. We have totally 8. So for that we have to use the 8 trials, that means 8 lines. So if you use the vector, then you can just simply vector, that means the array concept, then you can just simply declare one integer z, and you can use the for loop, because whenever it is 16 trials are there, then that will going to be difficult. If you write the line by line, then you can use the for loop. But here it is just declared as individual variables. So I just have to use 8 lines of code. So A equal to 0, B equal to 0, C in. So here I have that same thing. okay, here I have a equals to 1 tick b 0, that means 1 bit binary which is 0, then 1 bit binary that is 0. So whenever we have the 1, that is 1 bit binary, that is 1. Okay, so the meaning is like this. So here we have from 0 0 0 to 1 1 1. So I'm just going to copy and I'm just going to paste that. And even we have the 10 millisecond of the delay between it. Okay, I think now this is proper. We just have to click on this and uh, okay, yeah, just click on this test bench and ISM simulator, then simulate behavioral model. Now this will going to give us the output waveform. Yeah, this is what the output waveform. Okay, I just minimize it so that we can see complete waveform. Where's that minimization? Yeah, here we have that. I think now you can see that. So or totally there are 1 2 3 4 and 5 6 7 and 8 are there. So whenever 0 0 0 0 everything is 0, then if I just go to here, then here you can see the ABC in is 0 0 1, so the sum is 1 and the carry is 0. So whenever I click here, it is AB. Okay, B is 1, so sum is 1. So whenever I click here, both B and the C in is 1, so the sum is 0 and the carry is going to be the 1. I think you've understand about this waveform. For the time being, we just minimize this waveform and we have to implement this to the board. So here we have the board. I'm just going to keep like this and okay, I'll just go here, manage configuration project. So now this is going to open the window of that, and here we have the board. I think it's visible. So I just forgot one thing, that is the pinout, that is the user constant file or implementation constant file. We just have to add that. So just click on this and I think here, oh, it is doing. So I think we have to stop that, or it will going to take some time. Not here. Okay, this generating. I think there is some option to interrupt it. Okay, let it be, it will generate. Then we're just going to add the source file. Yeah, now it came. Then here we have the implementation constant file. This I just call this as a pinout. For simulation it is not needed. For the real implementation we have to do this. So now we have the three inputs that we use as these switches. Okay, these DIP switches we use as A, B and C, or instead of the, yeah, okay, we will use this. So here I have that pinout. So DIP switches, okay, the first three, I'm just going to choose this, and this I just have to copy. This is for our input, and the output which has the sum and the carry. So I have to use the two LEDs or anything you can use on the port. So T3 and T4, I'm just going to use the middle one. So T3 and the T4. So this is my sum, and this is my C out. Okay, C out. This name has to be same as here. This is the sum and C out, and A, B and C in. Okay, not here. A, B and C in. So here this has to be A, and this has to be B, and this has to be C in. Okay, C in. Now I just save this, and we just click on this one and manage configuration project. Or okay, now this will going to generate. Here make sure that you are clicked to the implementation, from the simulation to the implementation, and here we have the board. We'll just see, we need to program that. Okay, it is generating the programming file, that's the .bit files. So Yeah, now, yeah, it's generated. So it has to open one window, I think. Yeah, it opened here, I think. Okay, boundary scan. Then click on the initialize chain, and yes, we want to add the bit file. So here, just go to the directory where you created this project. So I have the full adder one, that same name, full adder dot bit. So click open, then this is added, then click no. This will become the green color. Okay, then click apply, then click OK. So click on this and click on program. So I think okay, again something, it happens like this. So we just re-upload this and we'll try. Okay, what I will do means I just change from that this switches to this push buttons. If this problem happens, you just have to do like that. Okay, that will absolutely it will going to correct that. So push button we have the 3, then we will change. Okay, so here this is A, and this is B, this is B, and this has to be the C. Then this are the in. Okay, C in. Okay, this is the simple and common problem that will occur when we try to uploading to the code to the board. So just click save. Then again I just have to generate the okay, so not this. Okay, generate program file, this one. Okay, this is the older one that I just closed this. So this is the older one that I have to just close this. Okay, yeah, now this will going to generate, it's synthesizing, and okay, I just disconnect this and I'll just connect it. Okay, yeah, it's generating. Just click on OK, then click OK, just boundary scan, initialize chain. Then here we have the same, that bit file we just have to add. So full adder dot bit, then this device, okay, just click a no, click OK. Now we just have to upload this program. So yeah, now it's working. Here you can see this the okay, this A and A B C, I think. So we just compare that with where is that, the table. So yeah, here we have that. So we just compare this with this table. Okay, so whenever the all are 0, this has to be 0, then 0 0 1, then I have to get the sum as 1. So the sum, I think LD3, okay, LD3 will be going to give 1. Then whenever we have all these things, all these 3 pressed, then this will going to give sum and the carry as 1 1, and whenever it is 1 1 0, so 1 1 0, only the carry is here you can see. Whenever I press the both, it will going to give the carry as 1 and the sum as 0. So for this one, okay, I think yeah, for this one I showed, and this one also I showed. I think you've understand this. Even you can change this to now to the DIP switches, and you can try. I just use the push button. So in the similar way, you can use the any ports or this DIP switches. I think you've understand this. Thank you.